Let's talk about graphing quadratic equations in standard form. So a quadratic equation in standard form just means that it's in the form y equals ax squared plus bx plus c. So it's not a good plus. So something like y equals 2x squared plus 3x plus 1, that is in standard form. That's good. Something like y equals x plus 2 plus x squared, that's not in standard form because it's the x squared is all the way on the right. It should be on the left. So how we make that into standard form is we write y equals x squared plus x plus 2. Get the idea? Alright. So how do we graph something like this? I'm going to erase this. So the way you graph something like that is you need to find where the vertex is first. So remember, we've always got a parabola, and whether the parabola goes up or goes down, there's always a vertex point here, or in this case, here. And if we can find the vertex point, then we can step like 2 times to the right or left of it, and then make our table to graph it. So, example, something we did previously was y equals x squared. Well, in this case, the vertex point is just 0, and then we can make a table x, y, 0, 1, 2, y is 0, 1, 4, and when we graph that, 0, 0, 1, 1, 2, 4, then we can just mirror it on the other side. That wasn't the best mirroring. Alright, that's a little bit better. Alright, but what do we do if it's like x squared plus 5x? No, let's make that 6x. X squared plus 6x plus 3, something like that. How do we graph that? Well, there's this handy formula. I'm going to clear this out and write it down. For the x-coordinate of the vertex. The x-coordinate of the vertex is given by negative b over 2a. Remember, in this case, a is 1, b is 6, and c is 3. Okay, so in this case, negative b over 2a is negative 6 over 2 times 1, which is negative 6 divided by 2, which is negative 3. So that means that when we make our table, x and y, we should start at negative 3. And then we can go to either side of it. I'm just going to go with negative 3, negative 2, negative 1, just because negative 2 and negative 1 are easier to plug into here than are like negative 4 and negative 5. So negative 3, let's see what we get for y when we plug in x is negative 3. So negative 3 squared is 9. I'm going to write it off to the side here. And then negative 3 times 6 is minus 18, then plus 3. So 9 minus 18, that's negative 9, then plus 9 is negative 6. Negative 2, well, this becomes 4. This becomes negative 12. This still becomes 3. 4 plus 3 is 7, minus 12 is negative 5. Negative 1, this is 1 now, minus 6, plus 3. This is 4 minus 6 is negative 2. So if we graph this thing, let's go to x is negative 3, go down to negative 6, 1, 2, 3, 4, 5, one more negative 6. That goes there. Then negative 2, negative 5, and negative 1, negative 2. So it should look like this. And just to prove to you that this is actually the vertex, when we go to negative 4 then, it should go back up to this spot right here. So negative 4 should come out to negative 5. So I'll put a question mark there because we haven't checked it yet. So let's just go ahead and check it. So this would go to 16. This one would go to 24. This one would go to 3. So that's 16 plus 3 is 19 minus 24. That is negative 5. Cool. Yeah, so that's how you can graph a parabola pretty quickly by finding the vertex. For good measure, why don't we just do a quick example with a downward facing parabola. So remember, what makes a parabola downward facing is when the x squared term is negative. Something like y equals negative 2x squared plus 4x minus 1. That would be downward facing because there's a negative 2 here. Let's go through the steps. We find that negative b over 2a is negative 4 over 2 times negative 2, which is negative 4 over negative 4. That comes out to 1. So let's make our table x, y. Now I'm going to start with 1 here and go 0, negative. I'm going to step back just because 0 is easier to plug in to this thing than 2 is. So when we plug in 1, we get negative 2 plus 4 minus 1. So that's negative 2 plus 4 is 2, then minus 1 is 1. 0, we plug that in, well, these terms go away. We just get negative 1. Then minus 1, this becomes still negative 2 minus 4 minus 1. So it's negative 6 minus 1 minus 7. So now we have a downward facing parabola. If we plot this, x is 1, y is 1, so it's right about here. X is 0, y is negative 1. X is negative 1, y is negative 7. Out here. So we should have something like this. Just to convince you of this still, because you should be skeptical. This is almost too good to be true. This is a really nice way to graph this really weird looking equation. When we plug in when we plug in 2 here, I'm gonna write it here. Yeah, when we plug in 2, wow, that's a weird 2. Sorry. When we plug in 2, what should we get out? Well, this is 1. This is at x is 2. That should be the same as x is 0, because that's like one step this way goes there. One step this way should go to the same spot, which was negative 1. So let's just check that that works. Negative 2 times, 2 squared is 4 times negative 2 is negative 8. Then 4 times 2 is 8, and then minus 1. These cancel. Yeah, it comes out to negative 1. Cool.